in the middle of the Jordanian desert, hidden behind a narrow mile-long canyon with walls rising 300 feet on either side. Sits a city that wasn't built, it was carved. The Nabataeans didn't construct Petra with stones and mortar. They sculpted an entire metropolis directly from the living sandstone cliffs, chiseling temples, tombs, homes, and theaters from solid rock with such precision that 2,000-year-old facades look like they could have been finished yesterday. The Treasury, Petra's most famous structure, features a 40-meter-high facade carved with such mathematical perfection that modern laser measurements show the columns deviate from vertical by less than 0.5 degrees. But here's what makes this truly impossible. The Nabataeans accomplished this working from the top down, hanging from ropes while carving intricate details into sandstone cliffs hundreds of feet above the ground, with no room for error, because you can't add stone back once it's removed. And they did all this while simultaneously engineering one of the most sophisticated water management systems in the ancient world, channeling every drop of precious desert rainfall through carved channels, ceramic pipes, and underground cisterns that allowed 30,000 people to thrive in a place where nothing should survive. This is Petra, and it represents rock-cut architecture and hydraulic engineering at a level that challenges everything we think we know about ancient capabilities. Petra's location seems almost deliberately impossible. It sits in a geological formation called the Shara Mountains in southern Jordan, surrounded by rugged terrain, and accessible only through the Siq, a natural gorge barely wide enough for two camels to pass side by side. The Siq winds for about a mile through towering sandstone walls that block out the sun for most of the day, creating a dramatic approach that suddenly opens to reveal the Treasury's magnificent facade glowing in shafts of sunlight. The Nabataeans chose this location strategically. The narrow approach was easily defensible, a small force to hold the Siq against a much larger army. The surrounding cliffs provided protection from desert winds and raiders. But most importantly, the sandstone was perfect for carving. The rock is relatively soft when first exposed, making it easier to work, but hardens upon exposure to air, creating durable facades that have survived 2 millennia. The Nabataeans were originally nomadic Arab traders who controlled the incense routes from Arabia to the Mediterranean. Frankincense and myrrh, essential for religious ceremonies and embalming, were worth more than gold, and the Nabataeans grew wealthy taxing caravans that passed through their territory. Around the 4th century BCE, they began settling permanently, and Petra became their capital, eventually housing between 20 and 30,000 inhabitants. Rock-cut architecture wasn't unique to Petra. It appears in various cultures worldwide, but the Nabataeans took it to unprecedented levels of sophistication and scale. Walking through Petra, you encounter over 800 carved facades, from simple cave dwellings to elaborate temple tombs with multi-story facades decorated with columns, pediments, and sculptural details. The Treasury, or Al-Khazna in Arabic, is Petra's most iconic structure and demonstrates the Nabataeans' carving mastery. The facade stands about 40 meters high and 28 meters wide, carved entirely from the pink-red sandstone cliff face. The design combines Hellenistic architectural elements, Corinthian columns, pediments, friezes, with distinctly Nabataean features, creating a unique architectural style. What's remarkable is the precision. The facade is symmetrical within millimeters. The columns are evenly spaced and precisely vertical. The horizontal elements are leveled despite being carved from irregular cliff faces. The decorative details, acanthus leaves on column capitals, figures in the pediments, friezes running across the facade, show craftsmanship that rivals the finest masonry work, except this isn't assembled from cut stones. This is carved from solid rock, meaning every detail had to be planned and executed perfectly the first time. The construction technique was revolutionary. Unlike traditional building that starts from the ground up, rock-cut architecture works from the top down. Workers would start at the cliff top, creating scaffolding or hanging from ropes, and begin carving downward. This approach means you can't fix mistakes. If you remove too much rock, there's no way to add it back. Every chisel strike had to be calculated and precise. Archaeological evidence and tool marks suggest the process involved multiple stages. First, workers would create a rough outline of the facade, removing large amounts of rock to establish the basic shape. Then increasingly skilled craftsmen will refine the details, working with progressively finer tools to create smooth surfaces and intricate decorations. The final stage involved polishing surfaces to the near-mirror finish visible on some facades. The tools were relatively simple: iron chisels, hammers, picks, and probably wooden scaffolding. The Nabataeans didn't have power tools, laser levels, or precision measuring instruments. They relied on careful observation, geometric knowledge, string lines for establishing proportions, and probably wooden templates for repeating decorative elements. The consistency of their work across hundreds of facades shows they had standardized techniques and quality control processes. Inside the Treasury, a large square chamber is carved from the rock, surprisingly plain compared to the elaborate facade. This suggests the facade's purpose was primarily symbolic and ceremonial rather than functional. Most scholars believe the Treasury was a royal tomb, though its exact purpose remains debated. What's certain is that it was designed to impress, to demonstrate the wealth and power of whoever commissioned it. Beyond the Treasury, Petra reveals itself as a vast rock-cut city. The street of facades features dozens of simpler tomb facades stacked into cliffs. The royal tombs, the urn tomb, the silk tomb, the Corinthian tomb, and the palace tomb, show architectural evolution and varying degrees of elaboration. Each demonstrates different approaches to rock-cut design, some more ornate, others more austere, reflecting different periods or possibly different family styles. The theater is particularly impressive, carved entirely from the living rock. It could seat 3,000 to 4,000 spectators in rows of seats following the hillside's natural curve. Unlike Greek or Roman theaters built with cut stone, Petra's theater was excavated from solid sandstone, requiring workers to remove thousands of cubic meters of rock while maintaining precise geometric proportions for proper acoustics and sightlines. But perhaps the most sophisticated aspect of Petra isn't what you see, but what you don't: the water management system. In a desert receiving less than 6 inches of annual rainfall, supporting 30,000 people required hydraulic engineering genius. The Nabataeans created a comprehensive system capturing, storing, and distributing every drop of water. Water channels are carved into the 6 walls, bringing spring water from the surrounding mountains into the city. These channels follow precise gradients, ensuring steady flow by gravity alone. At intervals, the channels widen into settling basins where sediment could fall out, keeping the water clean and preventing blockages. The Nabataeans use ceramic pipes, sections about 18 inches long that fitted together with conical joints, allowing some flexibility for thermal expansion and ground movement. These pipes were buried in carved channels or encased in mortar, creating pressure-resistant conduits that could carry water uphill using siphon principles. This hydraulic sophistication wouldn't be matched in Europe for over 1,000 years. Cisterns carved into the rock throughout the city stored water during wet seasons for use during dry periods. The largest cisterns could hold hundreds of thousands of gallons. These weren't simple holes in the ground. They were carefully designed chambers with vaulted ceilings to prevent collapse, plastered walls to prevent seepage, and sophisticated inlet and outlet systems controlling water flow. Dams built upstream from Petra captured flash floods, sudden torrents that raced through desert wadis after rare rainstorms. These dams diverted water into channels leading to cisterns or agricultural terraces, converting a destructive force into a valuable resource. The engineering required to build dams that could withstand flash floods while precisely controlling water flow demonstrates remarkable understanding of hydraulics and structural engineering. Agricultural terraces on hillsides around Petra show how the Nabataeans extended their water system to farming. Channels brought irrigation water to terraces where soil was built up behind stone walls, creating level planting areas. This allowed cultivation in terrain that would naturally be too steep and dry for agriculture, supporting Petra's population with locally grown food, supplementing what caravans brought. The combination of rock-cut architecture and water engineering reveals the Nabataeans as master engineers who understood geology, hydraulics, architecture, and their integration. They weren't just skilled stonemasons. They were comprehensive problem solvers who addressed the total challenge of creating a thriving city in an impossible environment. The decline of Petra began in the 1st century CE when changing trade routes reduced caravan traffic through the region. The Romans annexed the Nabataean kingdom in 106 CE, and while Petra remained important, it gradually lost its commercial dominance. A series of earthquakes in the 4th and 6th centuries damaged many structures, and by the 7th century, Petra was largely abandoned, known only to local Bedouin tribes who used it for shelter. Western rediscovery came in 1812 when Swiss explorer Johann Ludwig Burckhardt, disguised as an Arab Muslim to avoid suspicion, convinced a local guide to take him to the ruins. His accounts brought Petra to Western attention, and over the following 2 centuries, archaeologists, explorers, and eventually tourists flocked to see the rock-cut city. Modern study using technologies the Nabataeans never imagined has revealed more about their achievements. Laser scanning creates precise 3-dimensional models of facades, allowing analysis of symmetry and proportions. Ground-penetrating radar detects underground structures and water channels. Chemical analysis of plaster and mortar reveals construction materials and techniques. Each new study adds details to our understanding, while raising new questions about how the Nabataeans accomplished what they did. One enduring mystery is the workforce organization. Carving Petra's monuments required thousands of workers over centuries. How were they organized? How were skills transmitted from master carvers to apprentices? How did they maintain consistency across generations of construction? Unlike Egypt, where hieroglyphic inscriptions document construction projects, the Nabataeans left few written records about their building techniques. The precision achieved without modern tools continues to impress engineers. Establishing vertical and horizontal references on irregular cliff faces, maintaining symmetry across facades tens of meters wide, creating smooth curved surfaces in hard stone. All of this required techniques and tools we don't fully understand. Experimental archaeology has replicated some Nabataean carving techniques on a small scale, but recreating something like the Treasury, using only ancient tools, remains beyond current capabilities. The color of Petra's rock adds to its beauty and uniqueness. The sandstone displays extraordinary color variations: reds, pinks, oranges, purples, yellows, sometimes in swirling patterns within a single facade. This natural beauty, combined with the architectural sophistication, creates an aesthetic experience that's both natural and human-made, neither fully wilderness nor entirely city, but something unique. Petra today faces conservation challenges. Tourism brings needed revenue, but also wear. Millions of visitors annually touch facades, climb on structures, and generally stress 2,000-year-old carvings. Weather erosion continues, especially salt crystallization, where groundwater wicks through porous sandstone and evaporates, leaving salt crystals that expand and crack the rock. Occasional flooding still threatens despite modern water controls. UNESCO designated Petra a World Heritage Site in 1985, and Jordanian authorities work to balance preservation with tourism. Some areas are closed to public access. Conservation teams stabilize dangerous facades. Monitoring systems track environmental conditions and structural changes. But preserving rock-cut architecture presents unique challenges. You can't move it to museums or protect it with buildings without destroying its essential character as architecture integrated with landscape. Walking through Petra today, especially in early morning or late afternoon, when tourist crowds are smaller and light angles are dramatic, you can sense what the Nabataeans achieved. The scale, the precision, the integration of architecture and geology, the sophisticated water engineering, all combined to create something extraordinary. This wasn't a primitive people scratching out survival in a harsh environment. This was an advanced civilization that mastered their environment, created architectural marvels, and built a prosperous city in one of the world's most challenging locations. The Nabataeans prove that great civilizations can arise in unexpected places when engineering ingenuity meets environmental challenges. They took an inhospitable desert, identified its hidden resources, and through careful observation and innovative engineering, created a city that shouldn't exist but thrived for centuries. The rock-cut facades that remain are monuments not just to artistic skill, but to comprehensive problem-solving, to seeing possibilities where others saw only obstacles, and to the enduring human drive to create beauty and order even in the harshest conditions.